An attribute gauge classifies parts as acceptable and not acceptable. Usually parts well within the tolerance range are accepted most of the times, whereas those well out of tolerance are rejected. Parts that lie close to the tolerance limits, however, are susceptible to incorrect acceptance or incorrect rejection. The signal detection study measures the possibility of wrong decisions about the parts that lie around the tolerance limits. Signal detection study is typically done with 25 to 50 parts. Select the parts spanning across the tolerance zone. Some out-of-specification parts should also be selected. These help establish the capability of the gauge of correctly rejecting non-conforming parts. Maximum number of parts should be selected to cluster close to the tolerance limits of the gauge. These establish the gauge capability to resolve decisions in the zone of ambiguity. The actual values of the measured dimension for each part should also be logged. This is measured by a variable measurement system. Type in the tolerance limits for the gauge in the worksheet. We tabulate the observed results of signal detection on a worksheet of ProMSA. Accept is tabulated as 1 and reject as 0. Upon analysis, ProMSA orders the parts in an ascending order of measured value. The decision of acceptance and rejection is evaluated for each part. Parts clustered around the tolerance limits which are misclassified are logged. ProMSA evaluates the zone of misclassification as the R&R error of the attribute gauge. A signal detection R&R report is displayed. A signal detection study showing a high value of R&R prompts for improving the measurement process. As in the crosstab study, this may be achieved by appraiser training or robustizing the gauge.